Hello everybody, this is Design Minutes and I'm your host Yash. Let us proceed today by learning about load balances. Yesterday we went through the database layer and finished our basic architectures. We identified the fatal problems in the database layer, that is, in our previous architecture, the server acted as a single point of failure, and furthermore, vertical scaling was only possible, that is, we could not scale it horizontally. Now we will introduce a load balancer in our system in order to ensure that it becomes more scalable. The load balancer is a component which distributes the incoming traffic amongst the various web servers which are defined in its load balancing set. Therefore, this prevents a single point of failure in the servers. That is, since we have multiple servers and we can also scale them by adding more servers in the load balancing set, hence horizontal scaling is possible and the single point of failure of the servers ceases to exist. Also, in order to ensure that the load balancer itself does not become a single point of failure, we can add multiple load balancers in a complex architecture. Let us try to understand the architecture. The architecture is pretty similar to our previous architecture except with a major difference. The user first of all sends its URL to the DNS server, which resolves it and sends back the IP address. The IP address is actually of the load balancer and is a public IP, that is, it can be accessed by anyone on the internet. However, the load balancer has a private IP of the server, that is, the server cannot be accessed from anywhere on the internet. Rather, it can only be accessed through a private network which a load balancer and the server are a part of. Now, the server communicates with the database and performs CRUD operations. The database returns appropriate response, which the server forwards to the load balancer and which the load balancer finally returns to the user. Let us go through the advantages and disadvantages of a present system. As I mentioned earlier, a load balancer is highly scalable. That is, it allows adding more servers to our existing architecture by simply defining them in a load balancing set. Also, it prevents a single point of failure of the servers and allows horizontal scaling. Now, the problems with our existing architecture are similar to what I mentioned yesterday. That is, the database has too many operations in it and is still a bottleneck. Furthermore, the reads in the database are far higher than the number of writes, and we need to improve this by adding a master slave architecture. That is the topic for tomorrow. Thank you, and I'll see you in the next minute.